आइए अब हम बात करते हैं लोरीज एसे की, विच इज़ another method to determine the concentration of protein in any given sample. Lowry's method is an extension of Biuret method. इसमें हम प्रोटीन कॉपर कॉम्प्लेक्स के अलावा एक एडिशनल स्टेप देखते हैं टू डिटरमिन द concentration of the protein, which gives it more sensitivity as compared to the previously discussed method, that is the Biuret method. अल्कलाइन सोल्यूशन की मौजूदगी में कॉपर प्रोटीन कॉम्प्लेक्स बनता है और इस कॉम्प्लेक्स को फिर हम यूज़ करते हैं टू रिड्यूस द फोलेंस रिएजेंट. अब फोलेंस रिएजेंट की रिडक्शन इज़ गोइंग टू गिव अ ब्लू कलर टू द sample. So here is the same principle that if there is more protein, there is more complex of copper and protein in alkaline solution, there is going to be more reduction of Follins reagent, and ultimately the intensity of blue color is going to be more as compared to the those samples in which protein is present in less quantity. This method is highly sensitive because of this additional step in which Follins reagent is reduced, and that is the reason we can choose or we can prefer this method over Biuret method when we have to determine the concentration of protein having less amounts, that is 20 microgram up to 200 micrograms. यहाँ पे एक प्रॉब्लम है और वो प्रॉब्लम ये होता है कि जब हम इस मेथड को यूज़ कर रहे होते हैं तो Follins reagent की स्टेबिलिटी का इशू आता है. Follins reagent is stable at acidic pH, जबकि दूसरी साइड पे जो हम प्रोटीन सैंपल लेके चल रहे हैं दैट इज़ इन अल्कलाइन मीडियम, दैट मीन्स इट इज़ इन बेसिक कंडीशन. सो व्हेन वी ऐड Follins reagent in the protein sample which is having alkaline pH, there is likely a possibility that the Follins reagent is going to be destroyed or is going to be broken down and is not going to perform its particular function. Therefore, it is always suggested कि जैसे ही आप Follins reagent अपने sample में डालें उसको immediately mix करें so that the alkaline pH don't have any time to destabilize the Follins reagent and break it into its components. And that immediate vertex mixing makes it possible that Follins reagent gets reduced because of presence of the protein copper complex, and it gives the color that reflects the presence of protein. Now, Biuret reagent में हमने देखा था copper ion makes a complex with peptide bonds. यहाँ पे जो हमारे पास point of concern है principle के लिहाज से, the tyrosine residues. The tyrosine residues they carry the phenolic group. और ये जो phenolic group है that is capable of reducing the Follins reagent. अब Follins reagent को थोड़ा सा और डिटेल में देखें. It has two components, that is molybdenum, और इसको जब हम reduce करते हैं then we are going to get molybdotungstic acid. अब ये acid जो है that is going to be reduced in the presence of phenolic group of the tyrosine residues. प्रोटीन concentration तो determine हो गई, but आप देखेंगे कि same amount या same color intensity is not going to give you the same concentration. जितने amount number of tyrosine residues किसी particular protein में ज़्यादा होंगे, color intensity के ऊपर उतना ही difference आएगा. So therefore, we are going to have a variable degree of color intensity, that is blue color, depending upon the tyrosine contents. This method is sensitive because of this addition of Follins reagent, and it can help us determine the concentration of those samples which have protein in less quantity, that is 200 microgram up to 200 microgram, and the minimum level which we can determine is 20 microgram using Lowry's method.